Sharing neutrals in retail spaces has become a prevalent practice, offering enhanced flexibility and efficiency in electrical distribution systems. The neutral wire serves as a conductor that maintains a reference voltage in an electrical system, typically carrying unbalanced current from various circuits back to the source. Traditionally, neutrals were shared only for successive numbered circuits, such as circuits 1, 3, and 5 sharing a neutral, ensuring balanced current across phases. However, in modern retail spaces, it's now common to share neutrals between any two circuits, regardless of their specific numbers or phase, provided they are not on the same phase. This is facilitated by the use of neutral busbars, which connect multiple neutrals together. The benefits of sharing neutrals are numerous. Firstly, reduced cable cost is achieved by eliminating the need to run separate neutral wires for each circuit, leading to savings in both materials and installation expenses. Secondly, it increases flexibility, allowing for easy reconfiguration of circuits without the need to rerun neutrals. Thirdly, improved power quality can be attained, as proper neutral sharing can help balance phase currents and reduce voltage imbalances. Fourthly, simpler maintenance is realized by centralizing neutrals in a neutral busbar, making it easier to troubleshoot and replace neutral wires. Several important considerations must be taken into account when sharing neutrals. Neutral current balancing is essential to ensure that the neutral wire is not overloaded, which can create safety hazards. Excessive neutral current can occur if the phase currents are not properly balanced. The neutral busbar must be sized appropriately to handle the combined neutral current from all connected circuits. This ensures that the busbar can safely carry the maximum expected current. Each circuit should have its own circuit breaker or fuse to protect it from overloads and short circuits. This provides individual protection for each circuit and helps prevent damage to equipment and wiring. The neutral busbar must be properly grounded to ensure that it maintains a stable reference voltage. Grounding helps to prevent voltage fluctuations and provides a path for fault current to flow back to the source. The National Electrical Code, specifically the 2008 edition, provides guidance on the proper installation and use of shared neutral systems. It's essential to consult the relevant sections of the code to ensure compliance. These sections cover topics such as neutral sizing, grounding requirements, and overcurrent protection. When implementing shared neutral systems, it's crucial to use properly sized conductors for both the phase and neutral wires. The neutral conductor must be sized to carry the maximum expected neutral current, which can be higher in systems with non-linear loads. Also, ensure that all connections are made properly and are tight to prevent overheating and arcing. Loose connections can lead to increased resistance and potential fire hazards. Regularly inspect the electrical system to identify any potential problems such as loose connections, damaged wiring, or overloaded circuits. Addressing these issues promptly can help prevent more serious problems from developing. In addition to the NEC requirements, it's also important to follow any local electrical codes and regulations that may apply. Local codes may have additional requirements or restrictions on the use of shared neutral systems. The neutral is a current carrying conductor. The neutral conductor's function is to provide a return path for current. In a properly wired circuit, the neutral conductor carries the unbalanced current. This means the difference in current between the energized and grounded conductors and the neutral. The grounded conductor is intentionally connected to earth, establishing a 0 volts potential. The purpose of this connection is to limit voltage due to lightning, line surges, or unintentional contact with higher voltage lines. It also stabilizes the voltage during normal operation. The neutral busbar serves as a central connection point for all neutral conductors in a panel. The neutral busbar must be bonded to the panel enclosure, providing a path to ground. The neutral busbar connects all neutral conductors to the grounding electrode conductor. The grounding electrode conductor connects the electrical system to earth. This ensures that the system is properly grounded. Proper grounding is crucial for electrical safety. It provides a path for fault current to flow back to the source. This stripping of the circuit breaker or fuse protects against electrical shock. The size of the grounding electrode conductor is determined by the size of the service entrance conductors. Refer to NEC Table 250.66 for the correct sizing. Grounding electrodes can include metal underground water pipes, metal frames of buildings, concrete encased electrodes, and ground rings. Each circuit in a shared neutral system must have its own overcurrent protection device, such as a circuit breaker or fuse. This protects the circuit from overloads and short circuits. Circuit breakers are designed to trip when the current exceeds the rated value. Fuses are designed to melt and open the circuit when the current exceeds the rated value. The overcurrent protection device must be sized appropriately for the circuit. Refer to NEC Table 240.4 for the correct sizing. When working with electrical systems, always follow safe work practices. This includes wearing appropriate personal protective equipment, using insulated tools, and energizing circuits before working on them. Lockout-tagout procedures should be followed to ensure that circuits are not accidentally re-energized. Regular maintenance of electrical systems is essential for ensuring safety and reliability. This includes inspecting wiring, tightening connections, and testing overcurrent protection devices. A qualified electrician should perform maintenance on electrical systems. In retail spaces, shared neutral systems are commonly used for lighting, receptacles, and other equipment. These systems can provide significant cost savings and flexibility. However, it's important to ensure that the systems are properly designed, installed, and maintained. Sharing neutrals is generally safe, but it's essential to ensure proper current balancing between phases. Excessive neutral current can overload the neutral wire and create safety hazards. Neutral busbar must be sized appropriately to handle the combined neutral current from all connected circuits. Each circuit should have its own circuit breaker or fuse to protect it from overloads and short circuits. The neutral busbar must be properly grounded to ensure that it maintains a reference voltage. When sharing neutrals, it's crucial to consider the impact of nonlinear loads. Nonlinear loads, such as electronic ballasts and variable frequency drives, can generate harmonic currents. Harmonic currents can increase the neutral current and cause overheating. To mitigate the effects of harmonic currents, it's important to use appropriately sized neutral conductors and to install harmonic filters. Harmonic filters can reduce the amount of harmonic current flowing in the neutral conductor. In addition to the considerations mentioned above, it's also important to be aware of the potential for voltage drop in shared neutral systems. Voltage drop can occur when the voltage at the load is lower than the voltage at the source. This can be caused by long wire runs or undersized conductors. To minimize voltage drop, it's important to use appropriately sized conductors and to keep wire runs as short as possible. Voltage drop can affect the performance of equipment and can also cause overheating. When designing a shared neutral system, it's important to consider the load diversity. Load diversity refers to the fact that not all loads will be operating at the same time. This can reduce the overall neutral current and allow for smaller neutral conductors to be used. However, it's important to carefully consider the load diversity when sizing neutral conductors. If the load diversity is not properly accounted for, the neutral conductors may be undersized. The NEC provides guidance on the calculation of neutral loads. This guidance should be followed when designing shared neutral systems. The neutral load calculation takes into account the load diversity and the presence of nonlinear loads. In retail spaces, it's common to have a variety of different types of loads. These loads can include lighting, receptacles, HVAC equipment, and refrigeration equipment. When designing a shared neutral system for a retail space, it's important to consider the specific characteristics of each type of load. Some loads, such as lighting, may be more sensitive to voltage drop than others. Other loads, such as refrigeration equipment, may generate more harmonic current. By understanding the specific characteristics of each type of load, it's possible to design a shared neutral system that is both safe and efficient. Sharing neutrals in retail spaces is an established practice that offers significant benefits in flexibility, cost savings, and power quality. By understanding the considerations involved in following proper installation procedures, neutral sharing can be safely and effectively implemented in these environments. Always consult with a qualified electrician to ensure that shared neutral systems are properly designed, installed, and maintained. The electrician can perform calculations to determine the appropriate conductor sizes and can ensure that the system complies with all applicable codes and regulations. Proper grounding is essential for electrical safety, providing a path for fault current to return to the source and activate the overcurrent protection device, thus minimizing the risk of electrical shock or fire.